The arc of a baseball is an iconic projectile motion image. When the baseball is hit right at the bat, it rises into the air, falls back down at some, hopefully, great distance, if you're the batter. When it's hit, it has some I'm going to use light colors so that the darker vectors show up. It's hit with some initial velocity. The velocity carries it upwards and carries it along. If it's hit shallow, it's a line drive, scoots over second base and bounces into the outfield. If it's hit at about a 45-degree angle, then you have a chance for a home run. And if it's hit vertically or near vertically, perhaps maybe like this one, it's a pop fly, and even though it goes very high, it doesn't gain a lot of range. Also notice that as it travels from start to finish, at any level, except for the very top, it encounters that height twice. It encounters all heights once on the way up and once on the way down. That's the case in this problem. The height, so I will just read it says hitter, baseball leaves the bat. It says my initial velocity is, I'll write initial with an I. I think the book likes to use not, but 30 meters a second, so that's about 35 yards a second. The angle for me is equal to 36.9 degrees above the horizontal. And the first question is asking me, the first question, by the way, is the hardest. Part A is by far the most difficult, and I think we won't even do it first. But it's asking at what times. So as this, what time was it here, and what time was it here? So every height is reached at two separate points, except for the very peak, which was only reached at a single point in time. But there's a point in time here and a point in time here when any height, and that height for me is 9.5 meters. So there's a height here, height equals 9.5 meters, and that was reached on the way down and on the way up. So I guess this would be reached in time 1, and this would be reached in time 2. Now, how high a baseball, just like all projectiles go, is only dependent on the vertical velocity. So if this is our initial velocity vector here, we know what that value is. It's given. Its magnitude is 30, and its direction is 36 degrees above the horizontal. Now, 36 degrees above the horizontal is not very steep, so forgive me if I redraw it. I'm also going to draw it from down here, and I'm going to draw it a little more shallow, so it at least approximates 36 degrees better. All right, that's totally 36 degrees. And 30 meters per second. A baseball hit at this angle is carried along horizontally and is carried upwards. This can be called the vertical velocity, or the velocity in the y direction. This is the velocity in the x direction. We can make that explicit by laying down a set of axes right there. So this is the x x-axis now, right along at the level the baseball was hit, and this is the vertical axis, the y-axis. So now we can see that the velocity at some angle 36 from the horizontal carries the ball horizontally with some velocity and vertically with a velocity. These vectors together form also the sides of a right triangle. And we can use our knowledge of trigonometry and basic geometry to deal with the sides of a triangle. We have A, B, C, and we can use Pythagoras, which is a squared plus b squared is equal to c squared. Or we can use trigonometry to find vertical and horizontal sides. So this is also, given this angle here, 36 degrees, this would be considered the opposite side. This directly opposite of the angle. This is the adjacent side, and this is the hypotenuse side. So sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. All of those are useful. And why? Because depending on the kind of question that you ask, you need to understand motion in both the vertical direction and the horizontal direction separately. The vertical direction has an acceleration caused by gravity. Gravity is always pulling down. It's pulling downwards, and downwards on our coordinate system is negative. And horizontally, once an object is in the air, there's no forces on it horizontally, so it has no acceleration horizontally, and its velocity is a constant. So let's use those ideas to answer some of these problems. I think I'll start a new video though.